All right, so working through the review together from the back forward, because the back is where we probably need the most help, right? So 3x plus 2y is less than or equal to 24. Since it's in standard form, find your y-intercepts or your y and x-intercepts. If they're nice, then we can go about graphing it that way. If they're not so nice, we might have to change it so that it's y equals mx plus b form. These ones are pretty friendly, so I'm going to go ahead and just graph those. I'm going to have to figure out what my x scale and y scale have to be. I believe this is going to work out perfect. Zero, 12, if I go up by ones, is that very top. And 8 will show up on there too if I go by ones. I'm going to connect this with a solid line. Now, since x and y are both to the left of that, I'm going to have to test a point because I don't know which one I'm supposed to be. Since x and y are together, I don't have y is less than or greater than. So I can't say is y up or down because both x and y are on that side. So the easiest point to plug in is 0, 0. If I plug in 0, 0 to this, is 0 less than or equal to 24? Is 0 less than or equal to 24? Yes. So I know from this that I am going to be shading down. Okay. Then I go on to the next equation. X is greater than or equal to 2. What kind of line is that? A vertical line because it has to go through the x-axis at 2. Go to your x-axis, mark 2. Draw a vertical line through it. Solid line because it's greater than or equal to. X is alone. X goes left and right. Where is x greater than 2? To the left or to the right? Where is x greater than or equal to 2? To the right. So I'm going to go ahead, I'm going to put right arrows on this. Okay, I need another color. You don't have to color coordinate, but kind of if you want. I think it's a little bit easier to look at sometimes. Y is greater than or equal to 0. I'm going to go to my y-axis. I'm going to plot 0. Now what kind of line goes through that? Horizontal. It's a solid line. Sometimes it's hard to see because it's right when it's right on an axis, so make sure you make it nice and bold. And a lot of times I make it extend longer than what my graph does, so I make sure I can see where my pencil mark is. Okay? Now where is y greater, up or down from there? Up. So from here I'm going to draw all my arrows up. Now this is where your post-it notes come in. Did you guys bring your post-its back? Okay, so this is where your post-its come in handy. Here's my post-it on this line. I don't shade on that side. I'm only going to leave my arrows. I'm not going to shade on this side of the blue. And I'm not going to shade on this side of the pink. Okay, your post-its are going to be your friends on your quiz. I do have extra post-its that I can share if you need them. Then I'm going to shade. Then I can remove my post-its. And I didn't even have to practice coloring in the lines in kindergarten because post-its were so nice and makes it easy to color in the lines. All right, can we find our vertices? Where are our vertices on this graph? 2, 2, 9, that looks good. 2, 0 looks good. And what point is this one? 8, 0. All right, now we have to find the minimum. So what I'm going to do is I'm going to write out my vertices again. And I'm going to figure out the cost at each vertex. So go ahead and plug in those vertices to this cost equation. All right. right, so we get these for our cost. Now, we have to identify the minimum. So which one is our minimum? Negative 16 is the minimum. The minimum is at 8, 0 with a cost of negative 16. I don't care if you rewrite it or you circle it with an arrow, minimum, circled, however you want to do it, but I need to know that that is the minimum. Give me a 1 through 5 on this problem. How do we feel? Okay, moving on up then. We'll go to 15 next. Okay, what can I automatically see that my graph has to have in it? A V. How do I find the vertex of this V? Yes, take the 4x minus 12 equals 0. Solve it. What are you going to get for x when you solve it? 3. Is that okay? Plug in 3. 4 times 3 is 12. 12 minus 12 is 0. Cool, I should be getting 0 because I found the x that made it 0. What's the absolute value of 0? 0. What's 0 minus 6? So y has to be negative 6. There's my vertex. Okay. I think I should be good on here if I just go up by 1s. I'm going to plot the point 3, negative 6. Now that's my vertex. And I said I have to have a V, correct? Okay, now is that V going to be going up or is that the top of a mountaintop? This one's a V. How do I know that's a V? There's no negative in front of the absolute value sign. Remember, if that's a negative, that's the only way it could be an upside down V on mountaintop. Okay? So, if that is a regular V, how can I find more points if that's my vertex right there? Yes, use that 4. That 4 tells us how does it move from the vertex? Up 4, out 1. And I'm going to make sure that I put as many points on there that can fit. And then how do I connect this? With a solid line or a dashed line? Dashed. There's my dashed line. Okay, y is alone. So I can say y is less than. Where is y less? Up or down? Y is less than. That's how that reads. Down. So from all these points, I know that my shading has to go down. Okay. Cool. Now I'm going to graph the other one. Y is greater than or equal to 1/2 x minus 5. What does this look like on a graph? A line. That is a linear equation or a linear inequality. So that is just going to be a line. Okay, where do I start this line at? Where is negative 5? Because that's not a point. On what line? The y-axis. So I'd say the point is 0, negative 5. 0, negative 5 is right here. So that's my starting point. What are my directions from there? Up 1 to the right 2. I'm going to put as many points that will fit on this graph. Is this line solid or dashed? This one's solid because it's or equal to. This shading, does it go up or down? This one goes up because y is greater. All right, here my Post-it notes come in handy. I'm not shading on this side of the pink. I'm not shading on, this is going to be hard to do. We can do it a little bit at a time. This side of the blue and this side of the blue. Maybe I can even fold this. Cool. I made it work. So I'm not shading on that side of the blue. I'm not shading on that side of the pink. Cool, I can color it in. I am going to shade the entire graph that I see in that region. I'm going to shade this entire graph that I can see in this region. A little bit. Post-it wasn't quite perfect, so I'm going to go back and fix that. There we go. There is my shading. We good? All right, number 14. What does this one have to have in your graph? A mountaintop. Because that negative sign, you know that you're going to have a V. This one, though, will be a mountaintop. All right, let's find the vertex here. How do you find the vertex? Set the absolute value bar to 0. So 2/3 x plus 6 has to equal 0. 2/3 x equals -6. Multiply both sides by 3/2. The 3's cancel, the 2's cancel there. X equals -6 times 3 is -18. -18 divided by 2, that's just -9. Oh, that's not even that bad. Looked pretty ugly, but -9 is what I got. Cool. Plug it in. Maybe you don't want to do that by hand, so you use your calculator. Negative. Go to the math button. Hit the right arrow. Absolute value. 2/3 times your x value, which we got -9, plus 6. On the outside of that, add 5. I get 5. You know when you plug it into there, you should be getting 0. So the absolute value of 0 is 0. Make it negative. Still 0. 0 plus 5 is 5. So that makes sense. -9, 5 is your point. Plot the point -9, 5. I think actually we can probably make this, since that's all the way there and we're going to be shading down. Let's make this go by halves, then we'll take up more of our graph. You are allowed to make one scale 1 and the other one a half. You can have different scales on your x and your y. You just have to be careful with your slope. Okay? That's the top of our mountaintop. How does it move from there? It's going to be going down and out. How far down, how far out do we go? Down 2, out 3. But make sure that when you do this, you're using your scale. So down 2, out 3. Okay, I had to go down 2 on my y-axis that I created is actually down 4. Out 3 is still out 3. All right, and then how do I connect this? A solid line or dashed? Dashed. Now, I already said this, but how do I shade on this one? Y is less. Where do I shade? Down. So from all these points, I know I'm going to be shading down. Okay. How do I graph y is greater than or equal to 2? Horizontal line through what point? Through 0, 2. So go through 0, 2. Horizontal line, is this a solid line or a dashed line? Solid. Here's the solid line. Y is greater than or equal to 2. Where is y larger? Greater, above, or below? Above. So we're going above this line. All right, here's our Post-its. I'm not shading on this side of my pink. I'm not shading on this side of the blue. And for the V, you usually need 2 Post-its, so if you need more, let me know. There's my region. Cool. I'm going to shade it. Ta-da! I'm so good at coloring. How do we feel about this? Give me like a 1 through 5. I did it on my own and I got them right. I did them with you, but totally follow along. Totally get how to do it. I'm confident I'm getting all my points on my quiz there. Cool. 12 and 13 are very similar to the ones we just did. Do you guys want to go through those or do you want to skip those? You want to skip them and move on? Okay, if we have time, we'll come back to them. 10 and 11 are easier versions of the other ones because these ones don't have absolute values. They're just linear. Do you guys want to do 10 or 11? Not right now? Okay. And let's flip to the page before. 8 and 9. Let's go through one of these ones because this is different than ones we've done. Okay. Which one do you want to do first, 8 or 9? 8. Sounds good to me. So, how can I tell if 3, 4 is a solution? What do I need to do? Plug it into both. So, I'm going to start with the negative 4x plus 7, y is less than 20. I'm going to plug in 3, 4. So, negative 4, the x is 3. The y is 4. Pretend the right side doesn't exist. Simplify the left side. You could go to your calculator here and just type it in. What is negative 4? Trying to keep the right side covered up. Negative 4 times 3 plus 7 times 4. 16. So the left side is 16. The sign is a less than sign. Simplify the right side. Oh, the right side's already a number, 20. Is 16 less than 20? Does that mean my answer is yes? Not yet. I have to plug it into the second equation too, or the second inequality. So the second one says 8x is greater than or equal to 14y minus 40. I plug it in. 8 times x was 3, greater than or equal to 14y is 4 minus 40. Pretend the right side doesn't exist. What's 8 times 3? 24. My sign in the middle is a greater than or equal to. Pretend the left side doesn't exist. Again, you don't have to do that by hand. Use your calculator. 14 times 4 minus 40. I get 16. Oops. That's hard to read. Is 24 greater than or equal to 16? Yes. I answered yes to both. What's my overall answer? Yes. Okay, I want to do the next one because there's something that I want to show you on that one. Okay, number 9. When I plug into this first one, negative 4 times 3 plus 3 times 4 is greater than 0. I get negative 12 plus 12 is greater than 0, which is 0 greater than 0. Is 0 greater than 0? No. Do I need to move on if I've answered no? No, because the only way you can get a yes is if you answer yes to both. I don't care if it works for that second one, because this already tells me that your answer is no overall. Does that make sense? Now, what if it said 0 is greater than or equal to 0? Then it's a yes, okay? Because that question says or equal to. If it says or equal to, then that obviously works. Okey-doke. If we can do 8 and 9, then I'm confident that you guys know how to do numbers 6 and 7. How do we feel about that? You feel okay about that? All right, should we talk about the drama club then? I thought so. All right, the drama club was putting on a play to raise money. They were selling tickets with adult and children rates. Children were considered to be anyone under the age of 14. Adult tickets were $8 at the door, while children tickets were $5 at the door. If the drama club raised $600 and sold a total of 90 tickets Find the number of adult tickets sold and the number of children tickets sold. How do we define our variables? What is it? Close, but you would lose points on a quiz for that. It's not just children tickets. The number of children tickets sold. If I say children tickets, I don't know if I'm looking for the cost of children tickets, the number of tickets possible, the number of tickets sold. I don't know the details about the children's tickets. I don't know if I'm talking about the area of the ticket that was given to them. I don't know if I'm talking about the weight of the ticket given to them. I don't know what about the children ticket. So I have to be very specific when I define my variables about what I'm looking for. And if you actually look down here, it usually tells you whatever you're looking for. And you can use that as kind of a guide of how am I going to assign my variables. Okay? Y would then be the number of adult tickets sold. What is one of your equations? Because we have to come up with our system here. Go ahead.
5x plus 8y equals 600.
5 times x is 5 is the price of the children tickets. So 5 times the number of children tickets sold is how much money they raise from selling to kids, right? 8 times the number of adult tickets sold, that's the amount of money that they raise from selling to adults. If you add the amount of money you raise from kids and adults, what is the total amount of money they made? 600. That sounds really good. 5x plus 8y equals 600. That's one of them. What's the other one? X plus y equals 90. The number of tickets that we sold to children and adults together is 90. How come I did not use anything with this 14? It's irrelevant. It's extra information. I don't really care about it. That defines what a children ticket is. It defines that anyone under the age of 18 is a child, but that doesn't tell me how I'm going to find my answer of what it is they're looking for. Does that make sense? Okay. Solve using any method. So you can use any method here. What would be a good method to use? Substitution would be good because you can get x or y from the second equation alone very easily. What other would be a good method? Elimination, because they're already lined up with the x's, the y's, the numbers. They're already set up for elimination. So really, elimination or substitution would both work. I probably myself wouldn't choose graphing because I would know that here, my number 2, my x and y intercepts are both at 90, and that means I need a scale to go up to 90. And unless they cross at an exact line, and let's say I went up by 10s, unless they were sold in increments of 10, I probably won't be able to tell from the graph. So I right away would probably eliminate graphing dealing with numbers that were that high. Does that make sense? Because more than likely, if I sold like 37 and something else, I'm not going to be able to tell that from my graph when I go up by 10s. So I would use substitution or elimination. If I use elimination, you guys want to eliminate x or eliminate y? Sure. So I would multiply by negative 5 plus negative 5y. Negative 5 times 90, negative 450. This one would stay the same, so I would make sure I always write 1 and 2 together every time so that I can keep track and Mrs. Fox can keep track of my work easily and I get all my points for my work because when I have to show my solving and show all my steps, it's very important that Mrs. Fox can follow my work, otherwise I won't earn all my points. Those eliminate. 3y equals 600 minus 450 is going to be 150. Divide by 3 on both sides. Y would be 50. I guess this one would have worked with graphing because that's in an increment of 10. So, okay. Y was 50 and Y stood for the adult tickets sold. So that one's 50. Which means the number of children tickets has to be how many? 40, because I sold a total of 90 tickets. I would double check. I would plug those back into both of my equations there and make sure that they both work. Okay, and it does. That is the correct answer. Should we look at the first page? All right, let's look back to the first page. Yes?
So if the
It's only there because it says solve using any method. The graph is there. If you chose graphing, then the graph is provided. Where if you chose graphing and I didn't provide a graph, then how are you supposed to solve by graphing? So the graph is always going to be there if it says solve using any method, because if some people choose graphing, then that method needs to be there for ready to go. But no, you don't have to fill in the graph. Okay. Number 4, should we go through this one? Yes, okay. It says you have $4.50 made up of quarters and nickels. You have a total of 50 coins. How many quarters and nickels do you have? What should be my defining of my variables? What should X be? What should Y be? If I say X equals quarters, I don't know if I'm looking for the value of a quarter, a weight of a quarter, a diameter of a quarter, a thickness of a quarter, a number of quarters. Okay, that'll work. Number of quarters. What is your Y value? Number of nickels. I'm looking for quarters and nickels. So the number of quarters and the number of nickels. What is one of the equations that I have? X plus Y. So the total number of quarters and the total number of nickels has to be how many together? 50 coins in total. Does that mean I have 50 cents? No, because quarters are valued at a different cent than 1 cent, and a nickel is valued at different than 1 cent. My nephew the other day, my dad had given him, then he was pretending to trick or treat and practicing on all of our family members. He went up to my dad and said, "Trick or treat," and my dad put 2 coins in his bucket. And he says, "I have 2." And I was trying to tell him, and he's 3, so clearly he doesn't know the value of coins, but I was trying to show him that he had a quarter, and a quarter is a good one because it's 25 cents. And then he had a dime, so I was telling him he has 35 cents. But coins are cool because they're not all worth 1, right? So if you have 4 coins, it doesn't necessarily mean you have 4 cents, and you have to know the value of your coins. And you should all know the value of a coin, so of your basic American coin. So on a quiz, I will not tell you the value of a coin. Okay, you have to know that. That is something you guys need to know by your junior year of high school. You have to know how to add up your coins if you want to give the cashier perfect change. Okay, that is something I expect that you all know. All right, so the total number of coins is 50, but they don't have 50 cents. How much money do they have? $4.50. So how can I add up my total to figure out how they come up with $4.50? Yes, 0.25x. So the 25 cents times the number of quarters they have will tell you how much money they have in quarters. Add what to it? 0.05 times y will tell you how much money you have in nickels. Okay? How you write 5 cents is 0.05. How you write 25 cents is 0.25. Many people will tell me a nickel is worth 0.5. How much is 0.5 worth? 50 cents. Is a nickel worth 50 cents? No, you guys need to know how to write a nickel in terms of a dollar. Okay? Because that is in terms of a dollar. 4.5 is in terms of dollars. So when we write 25 cents, I want you to write it also as a dollar. It's $0.25. Is that okay? You could also put 1/4 there if you really wanted to. Isn't that crazy? A quarter is actually 1/4 of a dollar? How many people realize that? A quarter is worth 1/4 of a dollar, 1/4 of a dollar.
Never knew it.
Did you guys ever realize that?
No.
Some people are saying yes, some people look amazed right now. Okay, what method should I use here? You'd use substitution? I'd probably use substitution. I always go to substitution because I'm weird about it. I don't know why. Maybe it was because that was like the first one I learned after graphing when I was in 8th grade and learned this originally. I'm not sure, but I tend to go to substitution. One thing that might make this a little bit easier is if you actually multiply this by 100, you're putting it in terms of cents. So this would be the same as 25x plus 5y equals 450 cents. And some people like to write it this way because then you're not dealing with those decimals. And if it's written like that, sometimes people think it's a little bit easier to use elimination then because you're not dealing with those decimals. So either of these would be acceptable for that second equation. Okay? Or you could use elimination and then say, okay, multiply this one by -5, and I'd have -5x minus 5y equals -250. Add them up and your y's go away. 20x equals 200. X would be 10. X was the number of quarters, which means I have 40 nickels, and then I would add up my actual amount and make sure that that worked. How much money do I have in quarters if I have 10 quarters? $2.50. How much money in nickels do I have if I have 40 nickels? How many nickels make $1? 20. So I have $2 here. Do I have $4.50? Do I have 50 coins? Cool, I checked it.